All right, welcome back, everybody. Moving on to our next section in Chapter 3, 3-2. Today we're talking about properties of parallel lines. Objective to use properties of parallel lines. Let's get rocking and rolling with that. All right, now before we get into the node guide, let's just review kind of the same picture we talked about yesterday to get our lesson going. Okay, I've got some random city blocks here, not sure where they're from. What we talked about yesterday is within this picture, there's a whole bunch of different geometric figures that we already know about and a bunch of different properties we could look at, and there's some angles we could solve for and stuff like that. Okay, now after our last lesson, 3-1, hopefully something that's sticking out at you here is there are a whole bunch of lines and transversals, okay, happening all over this picture here. Okay, we also talked about how most of these lines are parallel to each other. Now, wouldn't it be nice if we had some properties, some kind of different theorems to work with about parallel lines and transversals? It'd be very helpful as I go to set up this city, figure out how much space I have on different blocks, figure out what the angles are. And that's what we're going to be talking about today. Basically, for each of those different angle pairs we gave you yesterday, we'll give you a property we can apply to it when the lines are parallel. All right, so first property we're going to give you is we're going to say it's the corresponding angle postulate. We'll say that if a transversal intersects parallel lines, then corresponding angles are congruent. Okay, so if I have parallel lines, and again, this only applies if the lines are parallel, with the transversal, each of my sets of corresponding angles, such as 1 and 5 in the upper left, will be congruent. Same thing with 2 and 6 will be congruent, 3 and 7 will be congruent, and 4 and 8 will be congruent as well. Okay, so parallel lines and a transversal give me 4 sets of congruent corresponding angles. Now, this property I'm going to say is a postulate. We haven't used that word in a little while. Postulate just means it's a statement that you can't prove is true. You just have to accept it as true. And by accepting this as true, by saying it looks true, that'll lead to a lot of different results we can come up with. So let's accept it as true. All right, so first question, problem 1, part A, which angles measure 55 degrees? So I have a geometric figure. We have parallel lines, so we can apply that corresponding angle postulate with a transversal. We're given one angle of 55 degrees, and we want to figure out which other ones are going to be 55 as well. Okay, well, first off, based on the postulate we just gave you, I know that angle 7 is also going to be 55. Okay, because 55 that I'm given and angle 7 are corresponding angles. I'm going to mark those as congruent. Okay, now back to chapter 2, I also have a set of vertical angles here, angle 1 and the 55. Okay, I know that vertical angles are congruent. So angle 1 will be 55 as well. And then the last one I have is this angle 5 here, and there's a couple ways I can kind of get to that answer. I have vertical angles between the 5 and 7, which we know are congruent. Okay, or 5 corresponds with angle 1. Either way, we have angles 7, 1, and 5 that'll all measure 55 based on this situation here. All right, that was part A. Why don't you take a minute, pause the video here, give part B a shot, and then hit play to check your answer. All right, let's go through part B. So I'm given 51 degrees right here. We want to know what other angles are 51. And again, I have parallel lines with the transversal, so my corresponding angle postulate applies. Now, 51 is going to be congruent with its corresponding angle, angle 5. Okay, 51 will also be congruent with this vertical angle here, angle 7. And then also whether we want to think as angle 4 as vertical with 5 or corresponding with 7, either way it's congruent. It'll be 51 degrees as well. So as you can see, we can use the postulate we just gave you to find the value of angles. Okay, we can use it to solve problems, figure out actual angle measures. Now, the other thing we can use postulates for is to come up with other properties, to come up with other theorems about our geometric figures. And that's what we're going to look at next is 3 theorems. So basically a theorem for each of our other 3 types of angle pairs. First one is the alternating interior angle theorem. It says that if a transversal intersects 2 parallel lines, then alternate interior angles are congruent. So once again, if we have parallel lines and a transversal, this time we'll have alternate interior angles congruent. 4 will be congruent to 6, 5 will be congruent to 3. Okay, I also have the same side interior angle theorem. It says that if a transversal intersects 2 parallel lines, then same side interior angles are supplementary. Okay, so again, if my lines are parallel with a transversal, this time same side interior angles will be supplementary. Okay, my color coding's off a little bit here. Let's fix that. Let's make that red. So in other words, angle 4 plus angle 5 will equal 180. Okay, then the other same side interior angles, we could say 3 plus 6 gives me 180 as well. And then our last theorem, the alternating exterior angle theorem, it just says that if a transversal intersects 2 parallel lines, then alternate exterior angles are congruent as well. So as in here, angles 1 will be congruent to angle 7, and angle 2 will be congruent to angle 8. So let's go ahead and use those properties. In problem 2, I've got a little more complicated geometric figure than we've been dealing with so far. Okay, a little more complicated because I have 2 sets of parallel lines. I know that line L and M are parallel because they both have a single arrow on them. And then I also know that lines P and Q are parallel because they both have double arrows on them. Okay, I want to use that information to figure out the measures of angle 3 and 4. Okay, and we'll state the theorem or postulate we use. So I want to know angle 3 and angle 4. Let's start off with angle 3. So how does angle 3 relate to the angle we know, this 105 here? Well, angle 3 and the 105 are alternate interior angles. We just said that when the lines are parallel, alternate interior angles are congruent. Therefore, angle 3 is 105 degrees as well. Okay, next up, angle 4. Now, how does that relate to our 105? Okay, the 105 and angle 4 in this case are same side interior angles. Now we know that same side interior angles are supplementary. Okay, not congruent, but supplementary when the lines are parallel. So to get angle 4, what I'll do is I'll take 180 for the supplementary and subtract the angle I know, the 105, which will leave me with 75 degrees. Okay, part B just adds a few more angles to this picture that we want to figure out. So why don't you go ahead, pause the video, figure those out, and then hit play to check your answers. All right, in part B, we've got the same figure. We're just going to add angles 2, angle 5, and angle 6 to the mix. Now, a nice thing about this problem is you don't have to do these in any particular order, so I'm going to go through them. Now, if you found things a different way but still got the same answer, that's just fine. Okay, let's do angle 2 first. Now, as far as how angle 2 relates to the angles I know, notice angle 2 is corresponding with this 75 degrees. Therefore, we know these 2 angles are congruent. And I'm going to use 2 arcs to mark them congruent as opposed to the 1 arc here. All right, therefore, angle 2 is 75 degrees. Okay, next up, angle 5. A couple ways I can think about this one. Since I already know angle 2, I know that angle 2 and 5 will be supplementary because they're same side interior angles, so we'll add to 180. Or I know that angle 5 is also just vertical to angle 3. Either way, I'll end up with 105 degrees for angle 5. All right, then last one, angle 6, how does it relate to the angles we have here? Well, angle 6 and this original 105 degrees are alternate interior angles. We know that alternate interior angles are congruent, so angle 6 will be at 105 degrees as well. I suppose the other thing we could have done for angle 6 is, since I have a linear pair here, I could have just subtracted the 75 from 180 and got the 105 there as well. Whoa. Whoa. So last thing we're going to do is add some algebra to the mix. Problem 3 says, what is the value of x for which line A is parallel to line B? Okay, so we have some lines that it doesn't give us are parallel with a transversal going through them. Now this question would be the same as A and B are parallel. What's x? We'll solve it the same way. Okay, so I have to set up an equation for this one. And now the first thing I want to ask myself is, what type of angle pair are we looking at? Okay, the two angles we're given here are same side interior angles. And we know that when the lines are parallel, same side interior angles are supplementary. So the way I'll set this up here is I'll say that 2x plus 9, the first angle, plus the second angle, the 111, is equal to 180. Okay? We can solve this then, combine like terms. 9 plus 111 is 120. And then we'll go through solving for x. I'm going to subtract 120 from both sides. And we get 2x is equal to 60. And then I'm going to divide both sides by 2. And we end up with x equals 30. All right, so if x is 30, that would make these two angles supplementary, which would make my lines parallel. All right, part B is a similar type of problem. Okay, it's not going to get set up the exact same way because we're going to be talking about different angle pair. But why don't you take a minute, one last time, pause the video, work through part B, and then hit play to check your answer. So same idea with part B. What's the value of W for which line C and D are parallel to each other? Okay, well, in this case, the angles I'm given are corresponding angles. Okay, so I don't have anything to do with supplementary here. We know that if the lines are parallel, corresponding angles are congruent. So the equation we're going to set up for this one is just that 55 is equal to 3W minus 2. And as far as which equation I set up, again, it's going to depend on what type of angle pair you're looking at. Okay, here we have corresponding angles. We know they're congruent, so we can just set those two angles equal to each other. Okay, let's solve this quick. I'm going to add 2 to both sides. That'll give me a 57 is equal to 3W. And then I'll divide both sides by 3. And we end up with W is equal to 19. All right, so there you go. That's section 3.2, building right off the work we did in section 3.1. Again, just giving properties to those different angle pairs. Okay, so start cranking through the homework, have at it, and like usual, if you get stuck somewhere, we're here to help you out.